So web audio, I know you just asked, but I missed it. Does somebody already experimented with web audio in this room? One guy? You can leave and go drink beers if you want, but I appreciate it if you stay. So today I'm going to talk about web audio, and I will be trying to add some effects to a guitar later as a live demo, which probably will go wrong because live demos are fun. But first, let me introduce myself. My name is Bellen. I work for a little company called Made with Love. I'm part of Frontiers Belgium, where we just organize meetups for front-end and stuff like that. You can find me on the internet as Sam Begel. So I'm a guitar player, and as a guitar player, I like to add a lot of effects to my guitar. At home, this is what I have in front of my amplifiers. It's just effects chained together to just make your sound different. And I started experimenting with making these pedals myself, which is just electronic circuitry and components and soldering and stuff like that. And that kind of worked, but since I'm a web developer, I was like, maybe I can do this myself on the web. And I've heard of this thing called the Web Audio API. So I just started to experiment, and I will take you through the process of what I thought would be the best solution to recreate this on the web. So is this possible in a browser? Let's hope so. The first thing we need to do is get the audio inside the browser, because my guitar is now connected through an external audio interface and then connect to my laptop. And it's actually just connected as a regular microphone. If you would plug a microphone to your computer, you can access that sound. My guitar now is exactly the same. It's a microphone. What you need to do to work with the Web Audio API first is create a new audio context. And with this audio context, you can start creating audio nodes and chaining them together and sending it to the destination of the audio output of your device, of my laptop. So getting the input, you can use navigator.getUserMedia, which will return a stream of audio. You can also get your webcam if you want, but for a guitar, we don't need that. This is deprecated and is now, can now be found under media devices, but it only works in Firefox and Chrome. So if you want to support a little bit of older devices, still use the old deprecated version. I don't, because I don't like older devices. So this will just return a stream, and with this stream, we can just start working with the Web Audio API. We use this stream to create a media stream source node, which is basically just an audio node which will use that stream, convert it into something the audio API knows, and lets you work with it. Then we connect our input node, which we created, to the audio context destination, and that's it. That's all you need to do to get your guitar sound through the speakers of your laptop, and that should work fine. I'm going to demo stuff later. Then, the most important part, add effects, because that was the main goal of my experiments. And I started with the most simple one, a volume pedal, because sometimes you just want to change the volume of your guitar. This can be done by using the gain node. The gain node will simply just let you alter the gain of your signal, going from 0 to 1, or from 0% to 100%, and everything in between. Like, you can see that I have my input node. I connect it to my gain node, which I just created, and which is at 50% volume at the moment. And then I create that gain node to the destination of my audio context. You can see that this just forms a chain of audio nodes beginning with input, gain, output. And it looks something like this. At 100%, you see that you have a nice audio wave. If you decrease it, you can see that the wave gets squished a bit. And if you go over 100%, it does just get cut off at the top and at the border. This is called clipping. If you want to make some dirty sounding sounds or effects, you can use this. Like, I will probably be using it later for some heavier tones on my guitar. But that's how the gain node works. It just decreases or increases the height of your audio waves. This is my chain, like I said before, input, gain node, output, simplest form of chain you can have, except the gain node you can also leave out if you don't want a volume control. The second effect I wanted to use is a distortion, or a fuzz, or whatever you want to call it. It's something which takes your guitar tone, which is a clean tone, and that it sounds like it's a metal or rock or a heavy sounding guitar. And we can make this using a wave shaper node. A wave shaper node is basically just a node that will take your audio wave, apply some mathematics to it, and change the curve of your audio wave. Now, I really suck at mathematics, so I was not able to come up with a formula for myself, but on Stack Overflow, you find everything. So what you do is you create a wave shaper, you set the amount of oversample 4 times is a max, and then you just give a function which will just calculate the curve based on your input audio wave, and it will alter your wave, and it looks a bit like this. My standard sine wave, basic audio wave. If you apply the function I found on Stack Overflow, you can see that the wave becomes much more squared, let's say, and you will hear this later. No, you will hear this now. I have this little sound effect. It's a simple guitar. If you apply this, you can hear that it's a little bit punchier, but with the guitar later in live, it sounds even better. So distortion, you use a wave shaper node, which will just shape your wave or your audio wave. It looks like this: input, wave shaper node, output. Same again, you just make a chain of all the stuff you want to do, and in the end you send it to your output or your speakers. The third effect I wanted to make is a delay. A delay is just an effect which will repeat your sound and gradually let it fade out. And good thing we have a delay node for that. Even though it's not as easy as you think just creating a delay node, you will see that later. But the basics of a delay node is just it will take your sound, delay it for an amount of time, and then play it. So in this example, it will delay your sound with 1 second. But this alone is not enough to really create the effect you want as a guitar player, the delay effect. So you have to get a bit more creative with the audio nodes you know. Here we send the audio signal to a gain, which goes to a delay, which goes to a gain, which decreases the audio volume, sends it back to delay, back and forth until the audio volume is 0, and then it fades out in the end. And it sounds a bit like this. So we have the audio, and then you can hear it go, and you can, of course, adjust the speed and the duration and stuff like that. But yeah, that's what a delay effect does, and that's what you can use a delay node for. Next up is a flanger, which is already a little bit more exotic. It's not really often used unless you play some psychedelic kind of music, which is totally fine. But I wanted to make this effect because it uses an oscillator node, which is a super cool one. What an oscillator does, it just creates a tone, a wave, like the waves I showed you before. It's just an oscillator creating a fixed wave, a sine wave in this case. So what you do is you create an oscillator, you set the type of the oscillator, like a sine wave or a triangle wave or a square wave or a sawtooth wave, and then you just set the frequency of that node. We humans can hear until 20,000, I think. Dogs can hear much higher, so you can annoy your dog if you want, but they will not like it. And you can see the different type of waves here. You start with a sine wave, it's just a nice smooth wave. You can change this to a square wave, which you can see is a bit more dirty. Triangle, mixed triangles. Sawtooth, a bit like a saw. And then if you increase the hertz or the frequency, you can see that it goes much faster and the waves are much more narrow. 2000s even more, and the sound. That was really loud, sorry. I'm not going to let you hear the rest of this stuff because, no. So to create a flanger effect, you have to get even more creative with some of the audio nodes. We've seen the gain node, the delay node, the oscillator node. You throw them all together, and then you let the oscillator, which is just a wave, control the time of your delay. So your delay time will go up and down and up and down, and you'll hear this nice washing effect in the background of your tone. Maybe you should put the volume a bit down for I demo this. So yeah, we have the guitar playing, and then you can hear in the background it starts to wash. And you can increase some of the parameters and stuff like that. You can make funky sounds with that if you're into that. But that's what a flanger does, and you can use an oscillator in combination with some other nodes to create this effect. Next up is a reverb. A reverb effect is like, it just adds some echo or some characteristics of a room to an effect. Usually it's echo or something like this. And for this we use a convolver node. A convolver node works a little bit different as that it needs an input response file, which is just an empty audio file, let's say, which contains some characteristics of a room like a big church or a big high building or a small bathroom stall, which you might know that every room has a different kind of sound when you talk in it or when you hear a sound in it. So this will just project these characteristics of that input response file onto your file, and you will hear an echo. So you fetch that file, you create an array buffer, you decode it into audio data, and then you just supply it as the buffer of your convolver node, which will sound something like this. Reverb. I don't know if we're going to hear it. You can hear there's some more echo or more characteristics to the sound instead of just a flat guitar tone. So yeah, that's what a convolver node does. You have to use a few nodes together as well, but as you can see in the middle is a convolver node which will just add the echo to your sound. So there's like 10 or 15 other nodes which I will not be talking about because I don't need them to demonstrate the effects I will show you today. But you have an analyzer node which you can use to analyze sounds, like my first slide had the representation of my voice in the cable. You can do stuff like that. A big filter node is just to filter some frequencies of your sound. Channel splitter node is to split it into more channels, like from mono to stereo or to 7.1 whatever Dolby. Channel merger node, the other way around, merge some channels back together. Panner node is to situate your sound in space, let's say, so from left to right, but if you have Dolby, it's also front to back. It's stuff like that you can do with this. And dynamics compressor node is just to compress your sound, that it has a more even feel to it. Like there's no super high or super loud parts, it's all even. But this, you've seen that creating these effects has, you have to get creative with a lot of nodes, and it's a bit of annoying if you want to remember all these nodes. So I created the audio effects library where you can just import the effect you want, add it to your input sounds, and hop, there you go. And now let's try this on a guitar. So I have this, let me just reload it. And we have my guitar already, which is cool. This is just getting the user input media, or the user media, and just playing it through the audio context destination. And you can hear that it's my guitar. Now let's add some effects. The volume, you know, it's just volume. Distortion. Stuff like that. You can hear that my guitar sounds like a guitar should sound. Then next up is the delay, which you've heard before. You can hear it wash in the background. Basically, all these effects I just showed you or let you hear, they also work on my guitar, which is pretty cool if you just want to experiment with some effects without actually going and buying those pedals because they cost a lot of money. My personal favorite, the Flanger. And I should tune my guitar. Sorry for that. And then there's also the reverb, which is just the echo, let's say. And you can really hear that the sound has some more body to it instead of just a plain old guitar. And then lastly, I just made a tremolo effect, which does this up and down going stuff. You might know it from Kill Bill. I think they made it famous. You can put it a bit. And then you play the right chords and you have Kill Bill and everybody's like, wow. Which is also just an oscillator controlling a gain node because just the volume is going up and down, up and up and up and down on a wave. So that's how you make a tremolo. But that's cool and stuff, but when you play guitar, you don't have your hands available to switch to effects on and off or adjust them. Luckily for us, there is the Web Midi Api, and I built this thing. You can buy some MIDI pedals if you want, but I am not like that. I like to build stuff. So I bought a Tessel. Does anybody know what a Tessel is? It's like a programmable stuff which you can program in JavaScript. I added some buttons to it. I connected to my computer, and now I should hopefully be able to control everything with my feet. And the Web Midi API is something like this. You just request MIDI access. You get a list of devices. You choose a device you want, and you listen to MIDI incoming MIDI messages, or you can also send them if you want. But in this case, I just want to listen to messages from my pedals to my computer. I also made this on the network, so I thought it was a good idea until you come into places like conferences where there's not always a good network connection. So let's see if it works. But yeah, I can turn on and off my effects. Nothing special, but that's what you can do with the Midi API, for example. You can really just control your computer or your website or your web app, whatever you want, with MIDI messages. Last but not least, let's do an experiment. We are making stuff on the web, and the web is just great for doing things together. So what if you guys could control the effects on my guitar? I think we'll get noise, but we can always try. If some of you have a phone or a laptop, you can go to this website. Let me quickly reload this. And then we'll see what happens. I guess it will be noise and feedback, but you never know. Maybe it's the next #1 hit. Is there some people on it already? No. This is the link. You can just choose a username. Huh? Nah. Looks like there's already a few people on it. And you can just control the effects. I forgot to put my input, so we have to start over, sorry. Do it again. All right. Which is... Finish. The thing about this is it doesn't really have to work. It's just cool that you can play around with it and let everybody enjoy the noise you make or you want to make, or just have fun. So that's it. Thank you. You can find my stuff on GitHub. This presentation is on my website. If you have any questions, shoot.
Thank you so much. I've always wondered what happens if you combine the power of music with the power of the web. Well,
Yeah.
we've just heard what happens. I'm not sure if anyone makes it. It makes anyone very happy. But let's continue experimenting,
makes me happy.
right? Yeah. Anyone have a question for Sam?
Yeah.
The lady in front.
So first of all, that was amazing, and I'm curious what you want to build next, or if you've tried this with any other instruments.
You can do this. Actually, you can connect any instrument as an input device to your laptop, like a keyboard, a bass. If you have an electric saxophone, whatever, you can connect it and put it through this, and it will work. You can also do it with your voice. But I am now trying to build a synthesizer with oscillator noise and adding effects to that stuff, which is totally web-based. So yeah, that's step #2.
I would suggest a keyboard flute. I love.
Yeah, I'm wondering, maybe I missed it, but in what browsers does it work?
It works in Firefox and Chrome. In Chrome, you have a little bit better audio quality. It's not really used, and you don't really have to do this stuff. It's not made for that, but you can do it. But in Firefox, you have really nice audio dev tools. So if you want to visualize your chain, like the little diagrams I made, you can visualize them in Firefox, which can be really nice to see what's going on into your audio chain. Yeah.
Thank you. And you know, there is in Australia there is a band just for with a robot musicians in it, and it's famous. I don't really remember the name. I'm not a fan of this kind of music. Maybe you can try to build a Belgium famous band with all the synth music.
Maybe I can,
Yeah,
but I don't really
go
like to
through
play
the
guitar in
computer.
front of people, so I chose the right talk to give in front of you all. But it's definitely an idea which somebody else could do. Yeah, there's somebody in the back.
One last question here.
Does it work on Android Chrome?
I have
you
no
haven't tried?
idea because I have no idea how to connect my phone, my guitar to a phone.
Because, you know, with iRig, there are a lot of applications that you can use on iOS for guitar processing. That's why I
iOS
wanted
does
to
not,
ask.
or Safari does not really support the Web Audio API and does not support Get User Media. But the Android Chrome browser is definitely better, so it might work or partially work on that one.
And one last, do you know Dasher's W, the one who wrote Pedalboard.js,
Yes,
the person?
yes.
Okay.
Is it you?
That was a personal question. He's Turkish and a friend of mine.
Okay,
that's why I
yeah.
asked.
All right.
You know him too. Okay. I think that were all the questions.
All right.
Well, anything you would like to add to this? No? If not, then I'd like to give you a round of applause and thank you for this great performance. Thank you, Sam.
Thank you.